Maham, sorry. Okay. And I'll monitor the Q&A section in the chats as well. Okay, people are starting to join. I can see that. Oops. Okay. Welcome, everyone. We're just gonna give people a minute or two to join. Okay. Welcome, everyone. We're just waiting for a few more people to join. Just giving them a bit of time. Okay, I think we'll just get started. So this call will be recorded and will be shared with everyone, at a later date. So welcome, and you're actually joining the sustainability track, and we have Anne Currie, who's going to be talking about to arrive at green software, you need a map. I'm not going to take away too much time from Anne's talk, so I'm going to hand it over to her. And then you can post questions through the Q&A tab, and we'll go through those questions at the end of Anne's talk. So over to you, Anne.
Thanks very much, Jen. So very happy to be speaking to you all today. So today I'm going to talk about how to go green. We need a map. My name is Anne Currie, and I am the author of O'Reilly's new book about sustainability, which is really entirely about aligning everybody so that we all move in the same direction, we're all making the same decisions, building green software. Now we are releasing that monthly. You don't even have to pay O'Reilly for an O'Reilly books. Read it. Because we're releasing it chapter by chapter monthly under a Creative Commons license at strategically.green, our website. And I am the CEO of Strategically Green, which is a training consultancy company. I'm also the developer, or we, as a result, all authors of the book, we got together with quite a lot of other people in the community to develop the Green Software Maturity Matrix, which is what we'll be talking about today. And it's not a Wardley map, but it's based on Wardley maps. We wanted to have something that was a little bit more simple than a Wardley map to put in the book, but which gave people a kind of an idea of the ecosystem and the environment in which we're building green software, and some guidance on what to do in what order. And as I say, that is what I would talking to us to you all about today. So before we get started, I think it's very important that I point out what I'm not here. I'm not a doomer. I think humanity is pulling itself together and we will survive climate change. I've been talking about this kind of stuff for 10 years. And during that time, we went from, I think there was a sustainability keynote kicking off MapCap 2019. I know that Simon came in for a bit of pushback on that because people were saying, oh, well, actually, climate change, it's a political issue. It's not a technical issue. It's not, the world hasn't agreed that it exists. How things have changed in the past 5 years. I think that now most people agree that it is happening. As Shakespeare would put it, the tide in the affairs of men has turned. We are now moving in the direction of building systems and software and everything else to accommodate climate change. But not all enterprises have yet realized that, and sustainability has to be part of their their strategy, not because it's right or wrong, or it is right, but that's almost immaterial. It needs to be part of people's plan because it's important and it'll take a while for them to do it. And that is the way the world's going. And if you don't get on board and go with the tide, you will spend the voyage of your life bound in shallows and miseries, which I find this Shakespeare quote to be really quite interesting for map camp and for maps in general, because to my mind, it encapsulates mapping. Now, I could be wrong. Everybody here is an expert on mapping, probably, but it'll be an interesting thing to discuss. I think I always think of mapping as a way of saying, well, look, this is the way everything's going. Make sure you go that way. Don't swim against it. And fortunately, I think handling climate change is now the tide, the direction that the tide is taking. So, physical reasons why I'm feeling more confident about climate change. There's a great chart here from Our World in Data, which is generally a sort of great charts about solar power generation worldwide. And I'd like to show that there's a similar, I could have shown you a similar chart for wind power generation, but it's not quite as super exponential. So I do quite like this one. Solar power generation, yeah, it's beyond exponential. It's amazing how quickly that's going, and that is a sign that that this technology is deployed at scale and can be made to work at scale. Now, solar and wind technology has been around for decades, and it's quite relatively recent that we've actually got it right in a way that it can be engineered for scale. And science can't always tell you whether or not something can be engineered. You also just have to build it, and as Simon would say, cross the river by the feel of the stones. You have to build it and see whether or not it can scale up. And the good news is that it really looks like solar and wind now, and their current designs can. And that is a game changer. Because then we're talking about effectively free power. Solar power is incredibly cheap. And there's plenty of additional scope for generating it. To a certain extent, it is the dream of humanity that at some point in the future there would be unlimited power, and I think that is now looking quite likely. But there is a huge issue here as well, which is hidden by that chart, because that chart agglomerates together all power production. And that's somewhat misleading, because renewable power, although it's very cheap, it definitely seems to have highly scalable potential. It is not. It has a major drawback as well, which is that it is not always available. It is not like fossil fuels. It is not available literally at the flick of a switch. There's a great William Gibson quote that he made in the 90s about the future, that it's here, just not evenly distributed. And I think that quote applies extraordinarily well. It wasn't what he was intending, but extraordinarily well to renewable power. There's incredible amounts of it, but it's not evenly distributed either in time or in space. There are some places where you can generate loads of wind or loads of solar, and sometimes that you can, but sometimes that you can't. Sometimes the wind isn't blowing, or it might even be night. And that is the new world in which we're living. We need to change our systems to take advantage of the amazing characteristics of renewable power, but also mitigate or deal with its downsides. It's not as always on or as easily available as fossil fuels. It is not so available at the flick of a switch. So this is the new world that we're living in, and this is the context for the maps that we built for Belgian Green Software. That in this new world, we've got solar and we've got wind, and it's cheap. It's still getting cheaper, and there's still plenty of untapped supply. But but it's very variable. It's only somewhat predictable. It's not always available, and it's not evenly distributed. There are places where you can generate a lot more solar, places where you can't, like the UK, for example. Although even in the summer, the solar availability is pretty good here. For both solar and wind, they're hard to ramp up. They have something that's called poor dispatchability. If you want more of it, it can be quite hard to get it on. It's not as easy to turn up on as fossil fuels. Ramp down is fairly easy, but it's something that feels wasteful. It's called curtailment, and it effectively means you're just going to throw the power away. So again, that is a kind of a key new thing we've never had before, that sometimes power is just like, we've got too much of it, we can't do anything with it, we're going to throw it away, which wasn't generally the case with fossil fuels, but is the case with renewables. So at times you might even be paid to use power. Now, we're generating amazing amounts of solar at times, for example, and in places, but it has to be moved somewhere else. And although we are exponentially growing our ability to generate solar power and wind power, we're not exponentially growing our ability to get it from one place to another. Grids are not necessarily growing exponentially yet. Now, we might say that it's impossible for grids to grow exponentially, but something which is analogous to a grid, which is the internet, is growing exponentially. It's still growing exponentially. But they don't do that. They don't do all of that growth by physically building new infrastructure. They provide a lot of it by being clever about the way that the internet is designed and used and controlled. And we probably need to do some learning from what the internet did to get grids to cope better with renewable power. And again, that's in very, very much in its early days. I don't think we've really got our heads around doing that yet. Short-term battery storage is good, but it does add cost, and it's unlikely to keep up with the enormous amount of power that is being generated by solar. So it's helpful, but it's not necessarily the game changer that effectively being able to use the power where and when it's generated would be. So I think that gives us the background there. I've given you the background there to that goes into answering a question that me and Sarah and Sarah, my co-authors of Building Green Software, get asked all the time when we say we've written an O'Reilly book on the subject of green software, which is, what is it? What is green software and what is a green system? And we used to have quite a technical term about minimal carbon emissions and all that kind of stuff. But over time, I've become, especially since we've actually got the book out and started talking about it, it's become clearer and clearer to me that actually what we're building is, what a green system is a system that is designed to run on renewable energy. There are other issues in the tech industry around embodied carbon in devices, but that's kind of separate to what we're talking about here in green systems. Green systems, green software is designed to run as effectively as possible on top of renewable energy, in my mind. And that means that it needs to support demand management. You have to be able to shift the work to times and places where there's renewable energy available, and shift it away from times when there isn't, when it's dark and when the wind isn't blowing. And that involves a fair amount of demand shaping as well, which is something that we do all the time on the internet, where we say, well, actually, the grid's a bit dirty at the moment. Let's fulfill people's demand, but by doing less. Let's do enough to keep them going. It's sometimes got in the energy industry, it's what is often called a brownout, that you turn down your lights a little bit, you automatically turn down the lights a little bit, so you've still got some light, but you don't have as much as you had before, but it's better than nothing. So graceful downgrades are what demand shifting is often described as. And these systems that are designed for renewable energy could also be described as systems that are designed for dynamic electricity pricing. Now, some of you might be aware of the concept of dynamic electricity pricing. It's common in Spain, it's common in a couple of US states, and also in some Scandinavian countries. And it's where the price of electricity from the local grid varies depending on how green that power is. And the reason is that it's actually just cheaper to generate green power than non-green power at the moment. So the idea is to drive people towards doing all the kinds of things that they might do that involve a lot of electricity, like charging cars or running tumble dryers at times where the electricity is cheap and therefore green. It might also be that there's not much competing demand, but fundamentally it is essentially greener. So this is all quite straightforward stuff. In order to be green, all we need to do is to start. We've got a measure which is effectively, or will be coming, which is the cost of electricity we're pulling out of the grid. We just need to get used to changing when we use electricity. So it seems quite easy. It's quite easy to understand. But we have a giant societal problem here that we're going to need to get over. And I think that societal problem is best illustrated by Simon's famous cup of tea map. And the problem is, in this cup of tea map, the problem is that power is at the bottom right-hand side of the map. It is the power that we have at the moment, the fossil fuel-based power, which is still where we are generating a great deal of our power. It's whether it's how we generate it or not, it's still how we see it. We are using fossil fuels to make sure that we are reproducing the situation that has been the case for the past 20 or 30 years. The power is reasonably cheap. As it turns out, it could be cheaper, but it's reasonably cheap, and it's utterly invisible to users. It's called something. It's called supply side response. It's saying that as a user of power, if I'm sitting in my house, I never have to worry about when I turn it on, and the cost is constant for me, because most countries are not using dynamic pricing yet. The cost is constant to me, and whenever I want to flick a switch and turn on my tumble dryer, why not? I might as well. It is an invisible resource as far as I'm concerned. So we're talking about low visibility, people don't think about it, and highly commoditized. And in order for, but as I've just said in the last slide, in order for us to take advantage of renewables, we need to start making power less invisible than it was. We need to start increasing the visibility of dynamic pricing, encouraging people to use power when there's loads of it available, and use less of it when there's less green power available. As we all know from mapping, moving things back to the left and up is quite hard. People like things being invisible. So how are we going to do that? How are we going to do that? That is we have to do it, but how are we going to do it? No, I know that not everybody here is in the tech industry, but my book is about the tech industry, and I think it's a good place to start. In many ways, we have the easiest problem to solve here when it comes to helping to move power to the left and back up the Wardley map again. We're already 100% electrified in the tech industry. All we need to do is reduce dirty electricity use in data centers to zero, which might seem like that's an incredibly difficult thing, but it's very easy compared to almost every other industry. So here is a good place for us to start thinking. And we also have the advantage of knowing what we need to do. There are a lot of levers that we need to pull. There are actually 6 levers, I think, broadly 6 levers that we need to pull. We need to decide where and who is hosting our systems, so the location of our systems and the hosts that we use and the tools and services that they provide for us to help us to demand shift, demand shape, be more efficient. we need to think about which architectures we use. Some architectures are easier to help with tools and services to demand shift and demand shape. For example, uh, distributed systems are often easier to match with demand shifting and shaping than monoliths are. We need to focus on operational skills so that we are using fewer machines to do the same work in order to, and then that will minimize how much power, what our base load is in the tech industry, how much power we need to do the kind of basic stuff that we need to run all the time and that we'll inevitably have to run when the grid is quite dirty. We need to be designing products that support demand shifting and shaping, that make it easy, that make it so that customers don't lose out too much as a result of it. And finally, we need to focus on code skills. So it's entirely possible to write systems that are up to 100 times more efficient by using much more efficient languages like Rust or even C. But I put that as the last lever because it's really quite hard to pull that lever. So we want to try and avoid it if we can. We want to buy it off the shelf rather than custom designing systems that are written in Rust or C, if we can. But the difficulty here is that, and this is the difficulty that all industries will be facing. We kind of understand what the levers are and what we need to do, but there's a lot of confusion about the order in which we pull those levers. There's a lot of it's really important that we pull them in the right way. It's very important that we don't kind of leap to the most difficult lever and try and pull it first without putting in the groundwork that will help us, or looking for services that would help us do that. So are we getting the help we need? Are we asking for the help we need? And are we attempting to do the impossible? And this was a question that was very much front and center of our minds when we wrote Building Green Software. Because we're very aware that me and my co-authors speak at a lot of conferences, and we were very used to at conferences at the end of a talk, somebody putting their hands up and saying, "Oh, I know what I need to do. I will rewrite my systems in Rust." And then often their boss, who was sitting next to them at the conference, they would go pale as the blood drained from their face, as because they knew that if they did attempt to rewrite their systems in Rust, their enterprise, their business would go out of business. It's slow, it's difficult. They didn't have the skills in-house to do it. It wasn't the right place for them to start, but it was almost invariably the place that everybody was thinking about starting. And we, as me and my co-authors, knew it was not the easiest place to start, it was not the most effective place to start, and it was not the right place to start. They were leaping straight to building a custom solution when we should really, following the rules of mapping, we should be looking for commodity solutions to help us first. Because this is a difficult thing to do. And if we don't get commodity solutions to help us, it's pretty much impossible. Now, we wanted to communicate a kind of simple, try and get across a simple idea for how people would get to the win here, which is something called 24/7 CFE for data centers, which is that for every watt drawn by a system in a data center, there is a watt going in from a renewable source, time matched in that location. So that's called 24/7 CFE. This is the term. 24/7 CFE is the term that Google uses. Microsoft, I've just learned, uses a different term, but I'm going to keep using 24/7 CFE. Total time matching, every watt you use balanced by a green watt going in at that same time in that same grid. So we decided to draw on a concept. We were aware of Wardley mapping, but putting a Wardley map into a book is quite difficult. There's a lot of people who aren't up to speed with Wardley mapping. We wanted to give people something a little bit simpler than that, because we were trying to get across a concept that folk were not that comfortable with. So we used something called a maturity matrix. Maturity matrices were was something that were invented at the Carnegie Mellon University in New York in the 80s. And they are a tool for delivering complicated management change. But they're quite simple to understand. They basically have two simple points that they're trying to get across. One is, what does good look like? What are we going for? And in this case, 24/7 CFE with a minimal number of offsets. But just as importantly, or even potentially more importantly, a maturity matrix says you do not attempt to get there in one go. They say, look, you are going to have to get there in stages, and you have to go through the stages. You can't leap over a stage. You have to go through the lower stages to get to the higher stages. And we use this to try and get across the idea to people that rewriting all these systems in Rust might be an amazing idea for reaching level 5, but it is not where you should start for almost all businesses. Where you should start is considerably more simple than that, considerably more basic than that. We really recommend, and the chapter in which we discuss the maturity matrix is already available under a Creative Commons license on my website. So do have a look at that if you don't have a copy of the book. What we start with is basic operational competence. And that means just taking a look at your systems every now and again, and statically, through static examination of your systems, reduce obvious egregious waste. So resize things that are oversized, turn off systems that you're not really using anymore. And in some ways, it's quite depressing, because you think, oh, well, this is just, it's easy to do. We should have done it. It's not really there's lots of other knock-on downsides to having a load of waste in your data center. But and so it's a bit depressing to just go through and have a look and say, well, actually, I don't really need to use that. And I've got lots of stories about who was it? VMware did a data center move in Singapore a few years back, and they thought they would do this at the same time, because doing data center moves is a great time at which to look at what you've got and say, do we actually need to move all of this stuff? And they thought, oh, well, I'm sure we'll find a machine or two that doesn't need to move. They found that they were over-provisioned in their previous data center by 66%. And this is VMware. You'd think that they were pretty good at running data centers, and they probably are, but they were still over-provisioned by 66%, which means, broadly speaking, they were also producing the 66% more carbon emissions than they needed to. So that is where we start, and almost all companies at the moment are at 1. We haven't even reached the point of basic operational competence. Where we need them to get is to level 2. Turn off machines that are no longer in use. Look to, and a rule of thumb we always say here, and this seems to work in practice, that you can usually cut your hosting bills and cut your carbon emissions by about 50% by just going through and turning off stuff and resizing stuff that you don't need. Then the next stage beyond that, say it's level 3, is to take that manual stuff that you did in level 2 and automate it. It is really the definition of exceptional operational skills. You're using DORA, your demand shifting and shaping. You've looked at your platforms, and you've checked to see whether they're green platforms that are really working on becoming more efficient and supporting demand shifting and shaping, and you're moving to them. And this level 3 is where the top that most enterprises are ever going to get to. Then you've got level 4, which is where you're really, really using your green platforms extremely well. Your green platforms are getting even better. But again, that is really, for most enterprises, about adopting those green platforms, adopting ones that are going to take you through level 4, take you through level 5 to 24/7 CFE without you having to do any more work apart from use those platforms as they were intended. And the obvious platforms that exist that are already at level 4 and are moving towards level 5 are the clouds. I know that the cloud comes in for a lot of kicking, and just moving to the cloud is not sufficient. For the cloud in and of itself is not a green platform. The cloud used in the way it was intended, i.e. you're using the services, you're using the tools, can be a green platform. It's not a guarantee. You have to actually adopt their architectural sustainability pillars and all that kind of stuff, but it has the potential to be a green platform. Not very many open source green platforms at the moment. That is something we need to work on. But the idea of a green platform is that you use your excellent operational skills and really good product management skills to adopt them, and then let them carry you through level 4 and level 5 all the way up to 24/7 CFE without you having to do any more work other than use those platforms as they were intended. So as I said, we get to 24/7 CFE gradually, starting with ops, probably over 5 to 10 years. And we do it using commodity tools for efficiency and demand shifting and shaping by adopting those green platforms, which are commodity tools that effectively support efficiency, demand shifting and shaping. And ideally following a map, like the GSF's Green Software Maturity Matrix. So I will leave you with this quote, and hopefully we can have a chat about maturity matrices and what we need to do next. Over to you, Jen.
Okay, thank you, Anne, for that great talk. So we're gonna open up the floor to questions, and anyone can post questions using the Q&A tab, or you can just really post your questions here on chat as well. It doesn't matter now. Okay, but I've got one question here for Anne from an anonymous attendee. How much is dynamic electricity pricing that you referred to as part of your green systems definition a feature in global majority contexts? It feels odd to me. Demand shifting, on the other hand, definitely happens worldwide, including in places where power is unreliable.
It's a really good question, because it is a common discussion point in the energy industry, that in many ways global majority is ahead of the more developed countries in terms of doing this, because developed countries have just spent the last 100 years getting completely and totally used to power on demand. And so we're really, really not at all used to thinking about things like only running the charging the car or heating the house or whatever we might want to do with power at times when the sun is shining or the wind is blowing. But in India, certainly, I've chatted to a load of people in India who are very familiar with with doing this. It's quite common in Africa as well, where they often have something called microgrids, where you have smaller grids where everybody is much more responsive to what's actually happening in the world around them, and changes their behavior. So yes, you're quite right. This is very much dynamic pricing is in many ways a way of trying to get the developed world, who have completely been, that had their mindsets changed by fossil fuel, to be in the supply side mindset where they just don't even think about it, and they use power whenever and don't think about how available it is, how green it is, and get everybody back into that mindset. Now there is an area where we are already in that mindset, and I think we need to learn from it. So we could certainly learn from the global majority, who don't have to change their mindsets anywhere near as much, and actually have quite a lot have tons of potential, often closer to the equator, have tons of solar potential, much more than the more northerly or southerly latitudes have. So there's tons to be learned there in terms of raising the visibility of electricity, but we also, but in developed countries, we do have a place in which to learn the techniques that we would need to apply to foster demand management, demand side response, and that's the internet. I mean, it might not seem like that's a direct analogy for the electrical grid, but it really is. On the internet, bandwidth, we've never been able to design systems that just assume that huge amounts of bandwidth are always going to be available on tap. I mean, you can do, and that's one of the reasons why systems designed in Silicon Valley can often be a bit rubbish when you take them out of Silicon Valley, because Silicon Valley has excellent bandwidth availability the rest of the world does not have. So often systems that are designed and tested there overly have an overly high expectation of high bandwidth availability at all times. Tools that are going to be used globally, and that's not just for the global majority, that is for everybody outside of Silicon Valley, have to be able to cope with bandwidth fluctuations. They do the bandwidth equivalent of demand shifting and shaping. Things like CDNs are an amazing example of bandwidth related demand shifting, moving stuff when at night when there's not much demand on the grid so that it's available closer to users when the demand is high. Shaping things like if in this video I start to my bandwidth starts to get poor, which might easily happen because I don't live in Silicon Valley, so my bandwidth is always fluctuating, then I'll suddenly become more pixelated, but my voice will be prioritized. We've got very good in the tech and in the tech industry at handling the internet and its variably available bandwidth. And we need to learn some of those skills and apply them to the electricity network. Sorry, that's gone way beyond your question, but it was an excellent question. Thank you very much.
Okay, great. Thanks for that, Anne. Next question. Do you have a map that shows your thinking behind the maturity map you prioritize for fabrication?
I don't, because I have a tendency to just draw these on bits of paper and then throw them away afterwards. I apologize.
Okay, thanks for that. Okay, so there's a question from Alexis Brooker. Interested why nuclear isn't more prominent or even mentioned when discussing CO2 reduction. I've seen articles covering data center proposals with on-site small nuclear reactors. What is your view on this kind of plan, Anne? And thanks in advance.
Well, I love it. I would absolutely love it if the problem was solved by nuclear, because it. The only reason why I don't talk about it that much is because nuclear is a like-for-like drop-in for fossil fuels, and I think that had we, it's a bit like the right time to plant a tree is the best time to plant a tree is 20 years ago. The next best time to plant a tree is today. The best time to have started transitioning over and getting ready for climate change was 20 years ago or 30 years ago with nuclear, because at that point nuclear is already on the right. It already demonstrated potential to be on the right side of a Wardley map. And nuclear is the main power in France. It can clearly scale as we need to provide global power, but we didn't. And in the meantime, solar and wind have got a lot better. They are very cheap and they are moving very quickly. So I think we need to start. I would have loved to have started 30 years ago, but yeah. But if you start today, then you probably are going to end up starting with solar and wind, just because they are now also commodity sources of energy, and they are quite cheap, and they really, really are very good for certain places and certain times. But I love nuclear, and I have no problem with having more nuclear. I consider that to be it's a carbon-free electricity source.
Okay, just checking here if there are any more questions. We've still got a few more minutes before we need to wrap up. Just checking. If there are any more questions from the audience, go ahead and drop them in the Q&A tab. Meanwhile, and are there any more things you're kind of busy with, aside from writing, all all these wonderful books?
um, so yeah, I mean, I do think that the the move to going green, to renewable power, is now inevitable, which is fantastically good. But it's amazing how many companies have not yet woken up to it and are not yet thinking, well, hang on a minute, how are we going to move what we do? So, I mean, it took the. I mean, the internet is amazing as a tool for reliably handling fluctuating bandwidth, and it grew from a very. But it took decades to get to this stage. We don't have decades, so we're going to have to learn from what we've already done, particularly in the internet, and apply it to energy grids now, so that we can compress what took 40 yees, 50 years for the internet into 10 years for renewables and a grid. So we really need to be keeping our eyes open and trying to get our heads around and getting started. Learn the skills. It's you have to be good at ops, and you have to be good at choosing green platforms. Those are the key sustainability skills for IT in the future, I would say.
Okay, thanks for that. Are there any more questions? I'm not seeing any at the moment. Just checking both chat and Q&A. Okay. I think if there are no more questions, I guess we can wrap up. Any last words before we wrap up? I don't see any more questions on the chat or Q&A tab.
No, I mean, so if you're interested in this, we are going to be running a book club for building green software there. And I've got a sign up page for that, which I periodically, and I will attempt to bring out more often on LinkedIn. So feel free to LinkedIn to me. And I'm also always available to chat on LinkedIn. So if you have any questions or you have any thoughts, feel free to reach out to me.
And maybe we can ask Jane to also share that link if you provide her with that. Also, I just want to say to everyone that this session has been recorded, so it will be shared with everyone, at a later date after the conference. And again, thank you, Anne, for that great talk, and thanks to everyone for joining. And there'll be a lunch break, I believe, from now until 1:30. And then the next session. So we will reconvene at 1:30, and then there's a keynote at 2 p.m. From Got Swetel. So if you want to catch that, come back in around 1:30, and then 2 o'clock for the keynote. All right. Thank you very much, everyone, and enjoy your lunch. Bye, Anne. See you
Bye.
around.